Hi, my name is Jason Brooks, and in this video, I'd like to introduce to you MLflow, an open source platform for the machine learning lifecycle. As its name suggests, this library was built to streamline and coordinate the work of data engineers, data scientists, and machine learning engineers. Here's a quick look at what we'll cover in this video. First, we'll start out with an introduction to MLflow. We'll take an overview of the library, and then we'll look at one of the features, MLflow tracking. With support from a strong community of contributors, its ease of use, interoperability across languages and libraries, and its ability to scale from a local environment to large servers, MLflow is the first choice of many industry leaders. Furthermore, by automating some of the more tedious parts of the machine learning process, it saves users a considerable amount of time. So, what is MLflow again? Well, it's an open source platform to manage the machine learning lifecycle. From data engineering to deployment to maintenance to ML ops, MLflow is a one-stop shop for all of your data science needs. And as you see, there are currently 4 key components: tracking, projects, models, and model registry. So that was the quick and dirty introduction, but now I'll continue with a high-level overview of the package, and towards the end of our time together, we'll take a closer look at tracking, which is a feature that lets users automatically track their experiments. We won't be able to cover all of the functionality, but I hope to get you started so that you can play with the platform on your own. So what we see here is the ML lifecycle. And why should we care? Well, on any given project, you typically start with some raw data, and after cleaning and preparing that data, a data scientist will train, experiment with different model configurations to optimize performance for a given use case. Finally, the model will be deployed into production. And with the addition of more data and the contributions of more collaborators, a project that may have seemed straightforward quickly generates more complexity than any one person can manage. As a natural reaction to this phenomenon, people divert energy away from solving the initial problem to managing all the moving parts of a project. This subtle but consequential shift in priorities can lead to delays, compounding mistakes, and costly inefficiencies. Furthermore, in this traditional way of organizing work, it's very difficult and time-consuming to move backwards to a previous stage of the process. MLflow was created as a solution to this genre of problems. But before we dive too deep, let's zoom out and take a closer look at the 4 main components of MLflow: tracking, projects, models, and model registry. So tracking, it allows you to record and query experiments. Their modular components are designed to simplify the lifecycle, and with a user interface, you can visualize experiments, compare model parameters, metrics, and predictions, and there's even support for Keras, PyTorch, and other popular modeling libraries. One of the main advantages of tracking is that you no longer have to manage experiments with spreadsheets by hand or with text files. The simple mlflow.autolog command allows you to revert back to previous versions of your model without having to rummage through your files to find older work. The second component is projects. It's a packaging format for reproducible runs on any platform. It also provides a project file to help organize dependencies so that any other data science can utilize a project you've created. So why is all that a big deal? Well, let's think about the typical data scientist. In order to share her work, she would not only have to track down and share all of a project's files, but also spend time matching up dependencies and versions across many libraries. Now she can use projects as a standalone tool to share and coordinate from the inception. This not only keeps an individual organized, but also keeps a team of people, some of whom will jump on and off a project at any given time, aligned and synced over time. The third component is models. It is a built-in integration, and with all of the popular deployment managers, including Kubernetes and Docker. This allows for easy deployment. You can think of models as a YAML file or a pickle file that holds all of the specifications and dependencies that allow you to deploy to diverse serving environments. Lastly, there's model registry. Similar to how you might manage different versions of software, model registry allows individuals and teams to edit, share, annotate, and manage models all in a centralized repository. For example, developers can deploy new versions of a model into a development stage without impacting the model in production. There's also batch and real-time scoring capabilities, along with a request feature that allows administrators to grant permission to collaborators, allowing for nuanced control over the modification of models. It's also easy and clear for all contributors to know exactly what stage a given model is in, production, staging, or maintenance. So now that you have an overview of the library, let's turn our attention to getting you started. So first, you're going to want to pip install MLflow, and after that, you're going to want to import the library. But before that, let's take a conceptual look at the way of thinking about tracking. As biologists and cave diving enthusiasts explore the undiscovered world of underwater caves, they use what's called a distance line. This tool helps them monitor their location at all times. And without this tool, one small mistake in this unforgiving environment can lead to disastrous results. Similarly, ML tracking automatically logs your work, which liberates data scientists to do more of the work they enjoy and excel at. So what does MLflow track? Well, as you can see, it tracks parameters, metrics, data, artifacts, the source code, in tags, and even comments. And this tracking feature is organized in two main concepts, or two main sort of features, right? The first is experiments and runs. An MLflow experiment is the primary unit of organization and access control for runs. And a run belongs to any experiment. An experiment lets you visualize, search for, and compare runs, as well as download run artifacts and metadata for analysis and other tools. And a run corresponds to a single execution of model code. And here's a snapshot of what that logging parameter looks like. So for the first one, you see the hyperparameters that are logged. And after that, you see the metrics that are logged, commonly used metrics that are logged. And then you can even log the model. Thinking more broadly, tracking is not only crucial to your ability to experiment with different models, but also from a business perspective, it allows companies to identify which models work best for their use cases. Additionally, it allows organizations to adapt to rapidly changing business environments, legal requirements, governance, and regulation. Given the increased scrutiny of machine learning and the need for explainability, automated tracking is an essential tool for the success of any data science team. We'll end our time here together, but I hope you walk away with a better understanding of MLflow, the four components of the library. Again, they're tracking, projects, model, and model registry. And finally, remember to pip install MLflow and at least try to autolog your next experiment. Give it a try and let me know how it goes. Thanks for watching. Good luck and have a great day.